All right, so here's a video for 3-5 simple and compound interest. So simple interest is a type of interest where it is calculated based off the percent of what's called the principal or the original amount of money. So basically you put money in an account and the amount of interest that is earned each year is based only off of however the original amount that you put in the account was. So the equation for that, or the formula that you can use to write an equation to represent the amount of money that you have after a certain amount of time. So A represents the amount of money. Is going to be PO, which is the principal amount or the original amount, plus PO times the rate times the time. So this is the amount of interest that you are paying. And that amount is being added to the original amount for every year or month that goes by. So again, PO represents the principal or the original amount of money, and you're going to multiply that by the rate of interest, and then multiply that by the time. So let's take a look at an example. It says, George puts $500 in a bank with 5% annual simple interest. Okay, so PO, or the principal, the original amount, is going to be $500, so that's going to be PO. And then the interest rate is going to be 5%, so that's going to be R. But remember that we should write that as a decimal, like we did with exponential growth and decay. So to do that, we move the decimal over 2 places, so it's going to be 0.05. So to write an equation for the amount of money in the account, it's going to be A of T. So that's just function notation. This first letter doesn't really matter. We usually choose a letter that matches the problem. So since we're writing an equation for the amount, that's why I'm going to use A. So that's going to be equal to the principal amount, which is 500, plus the principal amount again, so 500, times the rate, 0.05, times time, which in this case, since we're writing an equation, we're going to leave it as T. Well, this can be further simplified. We can actually take this and simplify this further. So I'm just going to do 500 times 0.05. That's going to tell us how much interest is being added each year. So that's 0.25. So the simplified version of this is going to be AT equals 500 plus 25T. So 500 is the original amount, and then $25 of interest is added for every year. And that 25 came from multiplying 500 times 0.05. So notice that this looks like a linear equation. It's basically in the form y equals mx plus b. It's just rearranged. So this is a linear. If we were to graph this, it would look something like this. So now the second part says, determine how much George will have in 5 years. So basically it's saying take 5, and we're going to plug that in for t here. So A of 5, so after 5 years, we're going to do 500 plus 25 times 5. So after 5 years, George has $625 in his account. All right, so now let's take a look at what compound interest is. So compound interest is when interest is calculated based off a percent of the previous year's balance. So this is called compounding interest. So the formula for compound interest is A of T. So again, A stands for amount of money, equals PO, which is the original amount or the principal amount, and then times 1 plus the rate to the time power, to the t power. So this should look familiar. This looks like our exponential growth equation, because it is, right? We take the original amount, 1 plus rate, and raise it to the time power. Okay, so let's take a look at this. So it says George puts 500. So same situation. The only difference is now we're looking at compound interest. So writing an equation for compound interest, it's going to be A of T equals The original amount is 500. And then we're going to do 1 plus the rate. So remember, 5%, we need to write that as a decimal. That's going to be 0.05. So we're going to do 1 plus that. So this is going to be 1.05 to the t power. So there's a equation that would represent the amount of money in the account after a certain amount of years. And now we can use that equation to figure out how much money George will have in 5 years. So we're going to plug in 5. So it's going to be 500, 1.05 to the 5th power. So the amount of money after 5 years in the account is going to be 638. So to contrast, this is what it was with simple interest, $625, but with compound interest, it was $638.14. So we'll have a little bit more with compounded interest. So after 5 years, we have $638, that's a money sign, and 14 cents. So let's take a look at another couple of examples. So starting with the first one on the left, it says Mrs. O'Connor got a 30-year home loan for $460,000 at 2.375% simple interest. If she made no payments for the next 30 years, how much money would Mrs. O'Connor owe? So let's first write an equation for the amount of money that she's going to owe. So for that, I'm just going to use the letter A again, just to be consistent. So since this is simple interest, we know that simple interest is going to be the original amount, which is $460,000, plus the principal amount, which is $460,000, times the rate, which is 2.375% as a decimal. We're going to move the decimal over 2 places, 1, 2. So that's going to be 0.02375. So 0.02375, and then times t. So to simplify, we're going to multiply the principal amount, $460,000, times 0.02375. So that's going to tell us the amount of interest for every year. So our equation is going to be A of t, the original amount, $460,000, plus 10,925 times t. So here's the equation that represents the amount of money that she would owe after a certain amount of years. So now it's telling us after 30 years, how much money is she going to owe if she makes no payments, meaning if she doesn't pay any to make that amount go down, how much money would she owe? So that just means we're going to plug in 30 for t. So 460,000 plus 10,925 times 30. So the amount of money that she would owe would be 52416. That's moving over 1, 2, 3, 4. And we still need to move it over 5 more places. 5, 6, 7, 8, 9. So the amount of money that she would owe is over $5 billion. So this is why you need to make payments on your home loans. So let me write this out a little bit more clearly. It would be $5,241,600 or $600,000 is the amount of money she would owe after 30 years. Okay, so now let's take a look at the second example. Let me just draw a line to kind of separate these two. So number 2 says Alonzo puts $6,500 into a savings account, which offers 1.2% compound interest. If he leaves money in there for 8 years, how much money will he have? So this is a situation where you're putting money in a savings account, and over time it earns interest, which means the amount of money will grow over a certain amount of time. All right, so this is compound interest. So I'm going to write an equation using A of t. So the formula for compound interest is the original amount, or the principal amount, so $6,500, times the rate, so 1.2% as a decimal, we're going to move it over to the left 2 places. So 1, 2. So that's 0.012. And we're going to do 1 plus that. So it's going to be 1.012 to the t power. So there's a formula for the amount of money. And then for this particular problem, it's telling us to plug in 8 for time. So we're going to see how much money we have after 8 years. So we're going to plug in 8. So 6,500 times 1.012 to the 8th power. So after 8 years, we have $7,150, and we'll round up to 85 cents. So after 8 years, $7,150.85. So here's kind of an example of interest earned on a loan, meaning you'll owe a certain amount after a certain amount of time. And here's an example where it's the amount of interest earned on some type of deposit where the amount of money that you have is growing. So that's the importance of having a savings account, right? You put money in there and the amount of money will just grow because it's sitting in a savings account. All right, let's look at another example here. So it says Jack wants to buy a car and he needs a $12,000 loan. Then it tells us that First Bank offers him a loan with 4% annual simple interest. And then we have another bank, Credit One, offers him a loan with 4% annual compound interest. So part A says to write an equation that represents the amount of money Jack would owe after T years for First Bank and Credit One. So for First Bank, we're going to call it f of t. So I'm going to use green for that. So f of t. So this one is simple interest, which we know is going to be the original amount plus the original amount times the rate, which is going to be 0.04 times time. So just to simplify this a little more, I'm going to figure out how much interest per year. So that's going to be $12,000 times 0.04. So that's $480. So plus $480 times t. So there's my equation for First Bank. And then for Credit One, that one is compound interest. So compound interest is going to be the initial amount, which is $12,000. Then we're going to do 1 plus the rate. So that's going to be 1.04 to the t power. All right, so now this says to complete the following table for each function to determine how much money Jack owes each year for each bank, assuming he makes no payments on the loan. So here we have the equations that we just wrote. Now we're just going to plug in numbers for t. So we're going to take these numbers here, and we're going to plug it in for t to figure out how much money he would owe. Okay, so starting with the first one, I'm not going to write this out each time, but maybe I'll write out the first one. So we're going to do 12,000 plus 480 times 1. So 12,000 plus 480 times 1. So after 1 year, so just to save some space, I'm just going to write it out here. What the answer is 12,480. Now we're going to plug in 2. After 2 years, he owes $12,960. After 3 years, he owes $13,440. After 4 years, he owes $13,920. And then after 5 years, he owes $14,440. Right, so we can see here that the pattern is just adding 480. So now let's do the same thing for Credit One. So for my first one, I'm going to plug in, can't remember what color I used. So I'm going to plug in 1 for t. So it's going to be 12,000 times 1.04 to the first power. So my new equation here, 12,000 times 1.04 to the first power. So same as the first year for simple interest. So 12,480. Now I'm going to plug in 2 for t. So I'm just going to change my exponent. $12,979.20. Now we're going to plug in 3. So $13,498.37. Fourth power, $14,038.30. And then lastly, the fifth power, $14,599.83. So just to compare these, it looks like after 5 years, you would be owing more on your loan using compound interest versus simple interest. So last question is, which bank should Jack choose for his car loan? And we should explain. So if we look back here, we can see, like I said, you're going to end up owing more money for compound interest. So, which is the Credit One bank, which means that he should choose First Bank. So Jack should choose First Bank because after the first year, I think it's the first 2 years, he would owe more money with compound interest. Which is what Credit One offered. So based off the amount of money and the amount of years that he would be taking the loan, he should go with First Bank. Simple interest would be a better deal. Okay, so now let's take a look at the homework here. So we're going to do number 1. So it says, Humberto brought a brand new 2021 Honda Civic. To pay for it, he took out a car loan for $22,000 at 2.5% simple interest. It says if he makes no payments over the next 5 years, how much will he owe? So first thing we need to do is we need to write an equation for the amount of money he owes. So simple interest is the original amount, so $22,000, plus the original amount, $22,000, times the interest rate. So 2.5% as a decimal is 0.025. So 0.025 times the time. So we can simplify this a little bit more to see how much interest he's paying each year. So 22,000 times 0.025, that's $550. So the equation is going to be $22,000 plus 550 times t. Okay, but then the equation's asking over the next 5 years. So that means we're going to plug in 5. So when we plug in 5, it's going to be $22,000 plus 550 times 5. Plus 550 times 5. So how much will he owe? He will owe $24,750. So he will owe $24,750 after 5 years.